In the name of Allah, who is the most beneficent and most merciful. I am Arid Fatma from MS Chemistry Department, and my ID is 2200314016. And I am going to present the topic Chemistry of Solar System. And this presentation is presented to Dr. Hammad Majeed. These are the contents of my presentation. First, I will talk about abstract, then general overview of solar system, origin of solar system, theories on the origin of solar system, structure, chemistry of planets, and composition of their atmosphere. Then I will talk about all the planets one by one and also explain about the chemistry and composition of their atmosphere. Now move towards chemistry of solar system. First, I will talk about abstract. The solar system investigates how long people have been aware of the planets and when planets were first identified, when their distance from Earth was first estimated, and how. Then, what is planet? And how planets are made, how radiations come to Earth, and what is the chemistry of radiations. Then, how does Earth protect us from UV radiations, and what are the differences between Earth and other planets? First of all, I will talk about general overview of solar system. Basically, what is solar system? Solar system is the collection of 8 planets and their moons in orbit around the sun, together with smaller bodies in the form of asteroids, meteorites, and comets. The planets of the solar system are Mercury, Venus, Earth, Mars, Jupiter, and Saturn, Uranus, and Neptune. And here is the picture of the planets according to the distance from the sun. And these are the planets are given in according to size. Why we call it solar system? There are many planetary systems like ours in the universe, with planets orbiting a hot star. And our planetary system is called the solar system because we use the word solar, and solar means it is used to describe things related to our star after the Latin word of sun for sun, solis. Because of this, we call it solar system. Then next is origin of solar system. Our solar system formed about 4.5 billion years ago from a dense cloud of interstellar gases and dust. And the cloud collapsed possibly due to the shock wave of nearby exploding star, which is called supernova. And when this dust cloud collapsed, it formed a solar nebula, which is a spinning, swirling disk of material. Origin of solar system. On the origin of solar system, there are various theories which are introduced on the origin of solar system, and I will talk about theories almost 6 which is introduced on the origin of solar system. Following theories are introduced on the origin of solar system: cometry hypothesis, second is planetesimal hypothesis, third tidal model, then Schmidt-Littleten accretion model, fifth is planetary collision theory, and sixth protoplanet theory. First is cometry collision hypothesis. The cometry collision hypothesis, which is basically proposed in 1749 by Georges Louis Leclerc, Comet de Buffon. It was the scientist which gave the idea that a comet struck the sun and broke off fragments which formed the planets. And this was the first version of cataclysmic hypothesis of the origin of solar system. Second is planetesimal hypothesis, a widely accepted theory of planet formation, the so-called planetesimal hypothesis, the Chamberlain-Moulton planetesimal hypothesis, and that of Viktor Safonov states that the planets which is formed from cosmic dust grains that collide and stick to form ever large bodies. The third theory is tidal model. Tidal model, this theory states that it states that a star passed by the sun and the star has a strong gravitational pull, which is so strong that it shredded some filaments from the sun. Then these filaments condensed and became planets and put into elliptical orbit by the gravitational pull of passing star. And this theory is proposed by James Jeans, English mathematician and astronomer in 1917. Harold Jeffreys, a British mathematician and astronomer, as well as a friend of Jane's and supporter of this theory, expressed doubts in this theory. He was concerned about the spin rate of the planets and the likelihood of a very massive star which is passing close to the sun. The fourth theory is Schmidt-Latin accretion model. Otto Schmidt is Soviet astronomer, which is also uh, who is also geophysicist and mathematician, proposed this theory in 1944 that the sun passed through an interstellar cloud. She might think of a nearby second star to take up energy from the cloud, but nonetheless stated that after that happened, the sun was enveloped with dust and gas that became the planets. And after Otto Schmidt, Ray Littleton, a British astronomer, states that it doesn't necessarily need a second star, but the circumsolar envelope with the mass and angular momentum necessary to form planets, which needs to be accreted. The fifth theory is planetary Cloyan theory. And this theory states that a rogue planet named Theia has come across the orbit of Earth, which is orbiting around the Earth. The resulting collision has affected Theia and Earth extremely violently and destroying much of the Earth and Theia and became vapor. The vaporized Earth and Theia combined into a giant atmosphere, and when it cooled, it became the present Earth and Moon. And the sixth theory is protoplanet theory. In 1960, Sir William Macquarie proposed the protoplanet theory, and it and he represent the sequences of two types. First is a collapse of a fast rotating interstellar gas cloud producing aggregates, and after this, the star was formed from the aggregates. Smaller aggregates formed into planetary disks and planets. And he also observed two lines. First is soot line and second is frost line. Basically, what is soot line and frost line? First of all, soot line. Soot line is a dark carbon-rich material that is present in terrestrial planetary disks, and this is also where the asteroid is said to be formed. And second is frost line. Basically, what is frost line? It is the distance from the solar nebula where it is cold enough to create water, ammonia, methane, and other volatile compounds. After the theories, I will explain the structure of solar system. The order and arrangement of the planets and other bodies in our solar system is due to the way the solar system formed. And how the solar system is formed. Nearest to the sun, only rocky material could withstand the heat when the solar system was young. And for this reason, the first four planets, Mercury, Venus, Earth, and Mars, are terrestrial planets because of the rocky material. And they are all small with solid rocky surfaces. Meanwhile, materials we are used to seeing as ice, liquid, or gas settled in the outer regions of the young solar system. Gravity pulled these materials together, and that is where we find gas giants, which is that are Jupiter and Saturn, and the ice giants Uranus and Neptune. Now, coming towards chemistry of planets. First, I will talk about the sun. The sun consists mainly of hydrogen and helium, two gases, and hydrogen is the most abundant element, which is accounting for over 90% of the atoms and 70% of solar mass. The next most abundant element is helium, which accounts for almost just under 90% of atoms and about 27% of the mass. There are only trace amounts of other elements, which includes oxygen, carbon, nitrogen, silicon, magnesium, neon, iron, and sulfur. And these trace elements make up less than 0.1% of the mass of the sun. The sun is constantly fusing hydrogen into helium, and elements heavier than helium form in the sun's core. They form in the convection zone, which is the outermost layer of the solar interior. Basically, what is convection zone? Convection zone is the outermost layer of the solar interior. Temperatures in this region are cool enough that the atoms have enough energy to hold their electrons. This makes the convection zone darker or more opaque because of this reason, trapping heat and causing the plasma appear to boil from convection. The motion carries heat to the bottom layer of the solar atmosphere, the photosphere. Basically, what is photosphere? Photosphere is the surface of the sun, a term which means sphere of light. The glowing wall of light that you see in the sky is the photosphere. The surface of the sun is the only part that we can see from Earth on a typical day without use of specialized equipment. Energy in the photosphere is released as light, which travels through the solar atmosphere, the chromosphere, and corona. Basically, what is chromosphere? Chromosphere is a layer, reddish and glowing layer of gas, which is above a star's photosphere, and sun is the star. Basically, it is above the layer of sun's photosphere. It is actually the transition between corona and the photosphere. Out of three layers of sun's atmosphere, chromosphere is the second one, with photosphere being the first layer and corona as the third. Now with then solar composition. Basically, what is the composition of sun? And the elements include in the composition of sun are hydrogen, helium, oxygen, carbon, neon, nitrogen, magnesium, iron, and silicon. And these elements I also explained earlier. And here is the percentage by volume and by mass. Now, what is solar energy? Solar energy is the radiant light and heat from the sun that is harnessed using a range of ever evolving technologies. Electromagnetic radiations. It is an important source of renewable energy, and its technologies are broadly characterized as either passive solar or active solar, which is depending on how they capture and distribute solar energy or convert it into solar power. And energy used for the cooling, heating, drying, distillation, power generation processes, it say. The earth receives 1,74,000 terawatt of incoming solar radiation, which is used insolation at the upper atmosphere. Most of the world's population live in areas with insolation levels of 150 to 300 watt per meter square or 3.5 to 7.0 kilowatt hour per meter square per day. And the energy radiated from the sun is electromagnetic waves, which reach the planet Earth in three spectral regions. And here is the wavelength of the all the three regions. First is ultraviolet, which is 6.4%, and their wavelength is less than equal to 0.38 micrometer. Second is visible region. Visible region is consists of 48.0%, and its wavelength is 0.38 to 0.78 micrometer, and infrared consists of 45.6% of total energy. Due to the large distance between the sun and the earth, which is 1.495 multiplied 108 kilometer, the beam radiation received from the sun on the earth is almost parallel. Now, these are the radiations which are coming from sun to the earth. And there are three types of radiations which are coming. First is direct, second is diffused, and third is scattered. First, I will talk about direct radiations. Solar radiation that reaches to the surface of Earth without being diffused is called direct beam radiation. Second is diffused radiation. As sunlight passes through atmosphere, some of it is absorbed, scattered, and reflected by air molecules, water vapors, cloud, dust, and pollutants from power plants, forest fires, and volcanoes. This is called diffusion radiation. Diffusion radiations basically are the radiations which can be absorbed, scattered, and reflected by any molecule. Third is global solar radiation. Global solar radiation, the sum of diffuse and direct solar radiation, is called global solar radiation. Now I will talk about extraterrestrial solar radiation. Solar radiation incident outside the Earth's atmosphere is called extraterrestrial radiation. On average, the extraterrestrial irradiance is 1367 watts per meter square. And here is the picture of Earth's diameter and atmosphere, which is about 8,000 kilometer, and Earth's diameter is about 12,800 kilometer. Now, terrestrial solar radiation. Terrestrial solar radiation is the energy released by the Earth itself, as opposed to solar radiation that it receives from the sun. Apart from the energy generated by the decay of radioactive minerals in the rock, the energy that drives terrestrial radiation ultimately comes from the sun, and it is also a major factor in the study of global warming. Now, how Earth protects us from ultraviolet radiations? Ozone is a colorless and very reactive gas which is can be found throughout all layers of our atmosphere. Most ozone, about 90%, is found in stratosphere, which begins at about 10 to 16 kilometers above Earth's surface, depending on latitude, and extends to an altitude of about 50 kilometers. Ozone in the stratosphere protects life on Earth from harmful ultraviolet radiation and is therefore often called good ozone. This is in contrast to ozone in the troposphere, which is the lowest layer of the atmosphere, and where it is an air pollutant and can be harmful to humans, animals, and vegetations. This is all about this part.